I'm Michael Wunsch. I'm the plant pathologist at the Carrington Research Center with NDSU. And I'm here to talk to you today about Sclerotinia head rot management. Those of you who tuned into this program last year might remember that I talked about this novel management strategy, utilizing honeybees to move a biological control to the sunflowers for management of head rot. And so we're going to talk about that. I did give a warning when I talked about that we had not evaluated the impact of the bags on head rot development. I'm going to talk about fungicide efficacy. I get the question about fungicide efficacy very, very frequently, and we're going to talk about that. We're going to talk about differences in susceptibility to head rot across commercial hybrids, and finally, the risk of Sclerotinia head rot relative to growth stage and temperatures. So first off, we are going to talk about this biological control strategy. The idea here is to utilize honeybees to carry a biological. So there's a dispenser attached to the honey to the entrance and exit of the beehive, through which the bees actually have to go through. They basically go through this little tunnel upon which a dispenser is depositing this biological control. So they come out of their hive to go out and pollinate and collect nectar, and they get the biological on their feet and their tummies, and they end up distributing the biological as they pollinate, which is really a nice concept, right? So the very initial testing with this was done in Langdon, actually with an oilseed sunflower, and this was basically the equivalent of a big industry, kind of strip trial, non-replicated, and so basically there was one batch of sunflowers exposed to the bees and the biological, and another batch, another location, not too terribly far away, but enough that the bees couldn't travel there in great frequency, where the sunflowers are managed equivalently. And so it's completely non-replicated, but spatially isolated, and every attempt made to manage the sunflowers similarly. Anyhow, I mean, as you can see from these results, the exposure of the bees was associated with reductions in head rot, and there was some noise in the yield data, but at least one of the trials, an increase in yield. But remember again, non-replicated studies, you could just very well have had conditions being a little less favorable for head rot in those two studies exposed to the bees, just because of the location and environment. All right, we followed this up in Carrington in 2018 and 2019 by using pollinator exclusion bags. You can see the beehive there on the left side, and then you can see the replicated pattern of heads bagged during bloom. We put these bags out right at very early bloom initiation, and then inoculated with lab-grown spores with the pathogen. And it's really a pain. You have to take the bag off, inoculate, and then put the bag back on. But that's the way that we kept the bees out of the control. You can see that we got similar results, maybe definitely actually quite a bit stronger results. But it obviously begged the question of, well, are the bags, which are used to exclude the bees, are they contributing to head rot by either trapping moisture or reducing the temperature on the head? And so we just to show you the additional testing we did with this, we did testing also where we had these long strips of sunflowers and beehives. These are half-a-mile strips of sunflowers and beehives distributed on one end and then 2/3 the way down. So we'd have a replicated study with evaluating the efficacy relative to distance from the hive. So if you take all of the data that we collected across the two unreplicated studies, as well as all these replicated studies using pollinator exclusion bags, and this is data Pollinator exclusion bags were utilized at the Langdon location from 2020 to 2022, and an on-farm site as well, close to Carrington, as well as in Carrington from 2020 to 2022. And so if you take all the data across all these studies and all the hybrids that we evaluated, mostly confection types, but some con oils, and again, a couple oil seeds at the very beginning, you can see that the exposure to the bees with unbagged heads was associated with 55% reduction in head rot, and that's statistically significant, a 31% increase in yield, and a 61% reduction in sclerotia in the grain. And this is actually really was the most exciting thing for me, because you can see that in all those studies were at or below that 4% by weight threshold that's required to maintain grade in a confection sunflower. Okay, but as I told you last year, we really need to do follow-up testing to make sure the bags themselves are not contributing to these differences, okay? And so we did the first year of that rigorous follow-up testing. And just for background, we did it with all the different types of bags that we utilized at different stages of this study. You can see in the upper left there, we can see this plasticky type bag that is porous to allow airflow and all that. But you can see in that one, I was always worried it would trap some humidity. And then you can see the bag that we utilized towards the end of the study, which is very porous, but definitely keeps out the bees. Anyhow, so that bag in the upper left is what I'm calling bag type number 2. The bag type number 3 is the one on the right side. And the other bag that we used in the first year of the study is very much like that one on the right side, but slightly larger holes. Okay, so here's the results from Langdon. This is a very rigorous study with 6 reps, 100 plants per plot, and so good sample sizes. And you see, we do not see statistical separation here, but look at this. Look at that increase in disease associated with using the bag alone. In this case, we have absolutely no bees anywhere near here. This is completely isolated from the bee vectoring study. This is not quite at the 55% reduction in disease that we saw in the bee vectoring studies, but it's certainly within the range of the responses that we saw over the years. And then we did the same study in Carrington, this time with all 3 types of bags. And you can see here we actually had a much greater difference between the unbagged heads and the bagged heads. And this is still within the range of what we saw overall in these bee vectoring studies, but you can see this is above the 55% reduction in disease. Okay, and certainly sclerosis contamination data there also reflect what we saw in those other studies. What's interesting here is that bag type 3 is that green bag, that yellow-green bag that was very porous. And in both of these studies, it actually was associated with the biggest increase in disease development. I mean, numerically, we don't have statistical separation between the bags, but it's the same trend in both studies. Bag type number 2, which is really plasticky and I thought would trap moisture, both studies were a little bit less. What this suggests to me is that we might be getting a real shading effect where that plasticky bag, probably retains some heat around the head, because basically just like if you put a plastic bag on something, it kind of traps heat. That bag type number 3, which allows a lot of airflow and is colored, I'm betting it was shading the heads and really dropping the temperature. I doubt it's trapping in humidity at all. And so if these bags are responsible for the apparent efficacy that we thought was being conferred by this biological control, then the mechanism here probably is that the bags are reducing the temperature on the heads and making the sunflower heads cooler and more and thus more susceptible to Sclerotinia head rot, because Sclerotinia, again, likes cool temperatures. So again, not definitive data. We only have 2 studies right now that are rigorous, looking at these bags, i.e. a good enough sample size and number of reps. But this certainly would suggest that any role that the biological might confer in reducing disease is probably not substantial enough to be worth the cost. Okay, because the bags are almost certainly giving the vast majority of the response that we were observing, which is very frustrating, very, very disappointing and frustrating. Just to follow up with this, there's always been a lot of talk that that exposure to bees can facilitate outcrossing and yield increases in sunflowers. Okay, and so we did conduct in the last 3 years an assessment of the impact of these bags with and without pathogen inoculation. And without pathogen inoculation, you're just relying on any ambient spores. And we established these studies on sites that did not have a history of Sclerotinia. And so the native disease pressure was very low. And what you can see here is actually what you would expect. 8 of the 10 studies that we conducted were conducted with those plasticky bags that would have really precluded the movement of the spores to the head from ambient inoculum sources. Okay, and so what you can see here is actually the bagged heads have a numerical reduction in Sclerotinia head rot. But again, those plasticky bags that do not allow a lot of air movement used in again, 80% of these studies would have impeded the movement of a lot of the ambient spores to the head. Okay, and that explains that numerical reduction and also the distribution you see there. That certainly leads itself to suggest that absent of actually artificial inoculation, we were getting less disease with the bags. But again, I think that's an artifact of the bags utilized in most of these studies. Okay, and you can see the same thing with sclerosis in the grain. As far as the yield response, this is a pretty good quantification of the yield response to exposure to outcrossing by bees and other pollinators, because again, these disease levels with Sclerotinia are very low and not a significant contributor to yield. And so you can see, okay, it looks like we're making about close to 85 pounds or so, okay, with the outcrossing, and not statistically significant, but it was actually pretty close to being statistical. Any rate, so I guess what I'm trying to say here is that the benefit to bees might be there in the absence of disease, but it's going to be very, very slight. And I guess if you're going to put out bees, I wouldn't be paying for them. All right. This pretty much sums up the conclusions that I've already shared. I do believe we do need to follow up on this research to make sure that these preliminary conclusions about the bags are rigorous and hold up to additional testing. But at this point, this is disappointing, and it does suggest a biological control. This particular biological control strategy may not be effective. All right, so fungicides. We did a very rigorous fungicide testing for Sclerotinia head rot, and we did this with very large plots. You can see that those are our driving passes in this field. This was a 13-acre field that we conducted. You can see the lines of pipe. We'd have to disassemble the pipe and reassemble it every time we went through to apply fungicide. And you can see we have strips of sunflowers. We only assessed for disease and yield the interior rows, okay? We certainly treated the entire strip, but only assessed the interior, because obviously we have edge effects there. Those alleys were put in, those driving passes were put in at late vegetative growth to minimize edge effects, but still, obviously you're going to have them. Okay, so we did testing with over-the-top nozzles and with drop nozzles. This is all tractor applied to be real world. I know drop nozzles are not really realistic in sunflowers. Who's going to do that, really? But we were really trying to rigorously evaluate whether there's any way to make fungicides work. A lot of people argue that with aerial applications, you can get great swirling of the product around the head and you can get it onto the head. Well, I doubt you're going to get any better than a drop nozzle. Okay, and so that's why we tested the drop nozzles. It was basically the best case scenario for fungicide deposition to the front of the head. Okay, so here we are with, we did a lot of testing with Proline and Endura. We did some other testing with some other products as well, like Miravis Neo. But I'm just going to summarize Proline and Endura because that's what we tested the most on. And what you can see here is that this is the change in Sclerotinia head rot and the change in yield relative to the disease pressure in the non-treated control, i.e. the percent of plants with Sclerotinia head rot in the non-treated control. What you can see is that when disease pressure was relatively low, less than 30% incidence, yeah, on average, we reduced disease a little bit with that fungicide application. You can see that all those dots are in the negative category, i.e. a reduction of disease. But look at that, that reduction is very small. Average 3% reduction. So if you are at 20% incidence in your control, you're down to 17% incidence with a fungicide. My bet is that you're not going to be real happy with that. Okay, and certainly when disease pressure got high, the fungicide got completely overwhelmed. And so look at the yield response. You can see that when Sclerotinia head rot pressure was relatively low, you got a pretty good yield response to that fungicide, but I can guarantee you it's not because of that 3% reduction in head rot. It's because of all the other diseases that you were managing with that fungicide application. Okay, and these are applications made during R5, either at the first third or middle third or last third of R5, and we inoculate with a pathogen after application. Okay, and so very good. Here we are with Endura, and what you can see here is that you know, very, very similar response, maybe the intermediate level of disease pressure, slightly better performance, but I mean, who cares about 4.5% percentage point reduction in head rot when you're at 35% in your control? I mean, 35 to 30, no thank you. It's not going to cut it. Again, the yield response to the fungicide goes down as disease pressure goes up, because really what you're getting your gain from is managing other foliar diseases. And as head rot becomes more and more important, the yield potential is wiped out, and any gains from controlling other diseases are wiped out. Okay, so here we are with drop nozzles. Okay, not surprising, we got better activity out of the Proline with the drop nozzles. Okay, see, we got some better activity there in that intermediate disease pressure level, but still, that's not commercially acceptable and certainly not worth the effort of going out there with a high boy sprayer and drop nozzles. Okay, same general response in terms of yield response to the fungicide. You're getting your gain primarily from managing other diseases. Here we are with Endura, very similar story as before, except here maybe the gain from using a drop nozzle is not as pronounced as with Proline. A little bit about fungicide residual activity. As I told you, we inoculate, we apply these fungicides at different growth stages, and then we inoculate with the pathogen. Well, we didn't always, we actually set this up in a randomized pattern where we would inoculate 1 day after, or 2 to 3 days after, or 6 to 7 days after we applied the fungicide. And what you can see from this pattern, this scatter plot here, is that you know, we had a fungicide residual problem. Essentially, if you got pathogen infection, i.e. us delivering spores in this case, very soon after you apply the fungicide, you got actually pretty good disease control. Okay, but you're looking at about maximum 2 days of residual activity. That's acceptable. Okay, and that's just not very good, right? But this makes lots of sense. Basically, the fungicides that's deposited to the open disc flowers, the disc flowers are a pretty big target. The open disc flowers and the senescing disc flowers, those are pretty big targets, and you can get enough fungicide to cover those. What you can't get enough fungicide to cover are all those little buds in the interior. So basically, if the infection occurs very shortly after you apply the fungicide, you know, that infection's going through those senescing blossoms that actually had pretty good fungicide deposition. Okay, and but if the infection's occurring to disc flowers that come into bloom 4 or 5 days later, I mean, forget it. You didn't get enough fungicide to those buds. Okay, so this goes back to my point. You know, I mean, this just doesn't work. Okay, okay, unless you're going to get infection in the next 48 hours, and you can get your fungicide on in front of that, it's just not realistic. You need more than 24 to 48 hours of fungicide residual activity to make a fungicide worthwhile. Other subjects that I was going to cover, I have discussed before, and I'll keep this extremely brief. And it's just that your main tool here is use of partially resistant hybrids. Nothing gives complete management, but some of the oilseed hybrids are quite good. Okay, and but under very high pressure, they will get overwhelmed by disease. The other big thing to remember is that the warmer the temperatures are, the lower your susceptibility to head rot. Okay, and so an earlier planting date that will get these sunflowers to enter bloom during the peak of summer when temperatures are higher will reduce your overall risk of head rot.